Hello everyone and welcome back to my channel. Today we will be diving into advanced Docker interview questions that will help you to sharpen your skills and also prepare you for those tough interview questions. So whether you're a Docker enthusiast or just getting started with Docker, this video is packed with valuable insights that will help you to succeed. So in this particular session, we will look at 15 advanced interview questions that you can expect as part of your Docker. Once again, before I start off with the session, please don't forget to hit that subscribe button. So let's get started with this. The first question I have is, what is Docker Swarm and how does it differ from Docker Compose? Now, Docker Swarm can be used whenever you want to create a cluster. So whenever you want to create connect multiple machines and you want to create a cluster, you make use of your Docker Swarm. So Docker Swarm is Docker's native clustering and orchestrating tool, and we can mainly use this to manage your cluster of multiple Docker hosts. So you'll be basically running multiple machines, and all these machines will be connected together, forming a cluster, and we call that as your Docker Swarm. Now, what's the advantage of this? Now, this ensures that your application is highly available, you get scalability, and you can also automate the management of these containerized applications across these multiple nodes that you have within your cluster. But whereas the Docker Compose, on the other hand, can be used when you want to run a multi-container Docker application. So whenever you want to define and run multi-container applications, you make use of your Docker Compose. So under this, we'll be basically have a YAML file where we will give the instructions, the multiple containers that you want to run. So Docker Compose is suitable for development and testing environments, whereas your Docker Swarm is suitable for production deployments and scaling your applications across your cluster across your multiple hosts that you're running within your cluster. The next question we have is, explain Docker networking modes, including bridge, host, overlay, and macvlan. So when we talk about your Docker networking, there are four main networking options that it provides. You have the bridge, you have host, you have overlay, and then you have the macvlan network. Now, the bridge network, that's your default network. So by default, whenever we are creating our network, by default, the containers will be running in the bridge network. So in this networking mode, each of your container will get its own networking space, namespace, and also IP address for each of the containers. Then you have the host network. Now under the host network, the container will be sharing the host's networking namespace, and this will allow the containers to directly access the host's network interfaces. So under your bridge network, you will essentially do a port mapping. In the host network, you won't be doing a port mapping. Then you have the overlay network, and this is what we use when we talk about your Docker Swarm. And this enables the communication between the containers which are running across multiple Docker hosts, which is your Swarm cluster, and it makes use of your overlay network for that communication. Then you have the macvlan network, which can be used to assign a MAC address, media access control, to your containers, and this will allow your containers to appear as a physical device on the network. So these are the four options we have. The next question we have is, how do you handle persistent storage in Docker containers? Now, by default, your Docker containers are ephemeral. What that means is the data on the container is available as long as the container is running. If you stop the container or if you delete the container, the data is also lost by default. But if you want to make your data persistent, Docker provides you a few options for that. So we can make use of your Docker volumes, we can make use of your bind mounts, and also we can make use of your external storage solutions. So when it comes to Docker volumes, these are your managed storage volumes, and this will help you to persist your data beyond the lifetime of your container. So in this case, even if you delete the container or if you stop the container, the data would still be available for you. Under your bind mounts, you are essentially mounting a directory or a file from the host machine where you are running your container, and this allows the data to be shared and persistent with your host machine. So again, in this case, even if you delete the container, the data would still be available on the host machine. And then in terms of your external storage solutions, you can integrate it with your NFS, EBS volumes on AWS, or Docker's volume plugins for storing data persistently outside the container environment. So essentially, you won't be storing the data on the host machine, rather you'll be storing it outside the host machine. Like if you're on AWS, you can definitely leverage EBS volumes to store the data. Next question we have is explain the difference between Docker images and Docker containers. Now, Docker images, these are your read-only templates. So this is where all of your instructions will be available, and we use this to create your containers. So Docker images are your read-only templates. So these images, they will contain everything needed for us to run our application. So it includes your binaries, your libraries, your dependencies, your code, everything will be available within your image. Docker containers, on the other hand, are an instance of your images. So whenever we use this image, we can create a container out of it, which is nothing but an instance of that particular Docker image. And this helps us to run an isolated process on the host machine itself, your Docker container. So containers can be started, stopped, deleted, and also moved between different environments, while your images are static and immutable. So once the image has been created, you cannot modify it. So that's why it's your read only templates. So you can think of your Docker image as an AMI on AWS, and the EC2 instance will be your Docker containers for your easier understanding purpose. The next question we have is, what are Docker secrets and how are they used for managing sensitive data? Now, Docker secrets, these are simply your sensitive information that you don't want to keep on in the form of plain text. Now, this sensitive information can be your passwords, your API keys, and your TLS certificates that you may want to use with your Docker Swarm services or within your containers. So these secrets are stored securely on the Docker Swarm manager node. So when we create the cluster, you'll have one manager machine. So all these secrets will be stored on that manager node, and these are only accessible by the services that have been given the access. So you can basically control which services can access the secrets. So these secrets are encrypted both at rest and also in transit, and this way it ensures that your secret data remains protected. All right, so we can utilize the built-in Docker feature to store your secrets, and then you can start using it within your containers. The next question we have is explain Docker multi-stage builds and the benefits of this. Now, Docker multi-stage builds, it mainly allows us to create more efficient and smaller Docker images by making use of your multi-stage builds within one single Docker file. So essentially under this, in one single Docker file, we will be defining multiple images. All right. So you can think of it as a smaller images. So you'll have essentially multiple build stages within one single Docker file. Now, each of this stage in the Docker file in the build process will have its own dependencies, will have its own tools, and this allows you to compile, test, and also package your applications without having any unnecessary files or dependencies in the final image. So your multi-stage builds mainly helps you to reduce the overall size of your Docker images and also improve the build time. So the time taken to build your images, that also can be improved by making use of your multi-stage builds. The next question we have is, how do you monitor Docker containers and orchestration environments in production? So again, Docker provides you with several tools that can be used to monitor your containers and also orchestrate the environments in your production environment. So you have options like Docker stats. You can make use of tools like Prometheus and Grafana. You can have Docker Swarm and Kubernetes dashboards, and also you can make use of your third-party monitoring tools. So Docker stat would be your built-in Docker command that is available, and we can use this to monitor your resource utilization, such as your CPU, memory, network of all of your running containers. Then you have your Prometheus and Grafana, which can be used to uh, collect the metrics and then visualize this data from Docker containers, host, and your orchestrators. You can also make use of your Docker Swarm and Kubernetes dashboards, which are your web-based interfaces for monitoring and managing your Docker Swarm and Kubernetes clusters. You can also leverage third-party tools like Datadog, New Relic, Sysdig for comprehensive monitoring and alerting capabilities. So you have lots of options, lots of integrations that are available. The next question we have is explain Docker health checks and how are they used to monitor container health. Docker health checks, these are simply a feature which basically helps you to run a periodic check on your container and get a status report about that particular container. So, this is essentially to make sure your container is healthy or not. Now, these health checks can be configured to either run some custom commands or scripts to basically verify the overall health of the container. So, it can be making a HTTP request to an endpoint or checking the status of a service, which will help us to determine whether your container is healthy or not. So Docker orchestrators like Docker Swarm and Kubernetes, they make use of your health checks to monitor the container health and also automatically restart these containers or reschedule any unhealthy container. So this is essentially to make sure your containers are running as expected and there are no issues with the containers. And if there are any issues, we can also automatically restart those containers or we can reschedule any unhealthy containers. And this way we can make sure that your containers are working as expected and we don't have any problems with them. That's where we can make use of your health checks in Docker. The next question we have is what are Docker plugins and how are they used to extend Docker functionality? Now, Docker also provides you with many plugins which helps you to add additional functionality and capability to the Docker. And this also allows you to customize and extend the Docker features. So, any customization, like let's say you want to utilize external data storage, you can make use of your plugins for that. So, plugins can be used to integrate with external storage systems, networking solutions, logging drivers, volume drivers, and many more. All right. So Docker plugins, these are implemented using the Docker plugin API, and they can also be developed by the community, or you can also have a custom build based on your use cases. So plugins, they mainly help you to enhance the capability of your Docker. The next question we have is explain Docker build caching and its impact on image build times. So Docker build caching, that's a feature of your Docker which mainly helps you to improve the performance of your Docker image builds. And how this does it does this by creating a cache of your build stages and dependencies. All right. So let's say we're using Docker and we have defined a Docker file, and then using this Docker file we create an image. Now this image basically consists of your layers. So we'll your base image, your from instruction, your run instruction, your CMD instructions. All these are your layers within your Docker image. So whenever we are building an image, Docker will check if the build context and Docker instructions have changes since the last build. So essentially what happens is the next time when I build an image using this Docker file, my Docker will check if there are any changes in this Docker file. Only if there are any changes, it will go ahead and build a new image. And if there are no changes, it will utilize the cache. So whatever the existing image that we have created, we will have cache available for that, and your Docker will simply reuse that. If not, so like I said, if there are no changes, Docker will reuse the cached layers and only rebuilds the parts of that image that have changed. Okay, so this will help you to significantly reduce the time taken to build your images, especially for large projects with many dependencies. The next question we have is how do you manage Docker Swarm secrets across multiple environments, which can be your development, staging, and production. So Docker Swarm secrets can be managed across multiple environments, and we can make use of your Docker's built-in secret management features for this. So secrets are scoped to individual Docker Swarm services, and they can be replicated across different environments using the configuration files of your Docker Swarm or your Docker Compose files. Additionally, Docker also provides you tools for managing deploying secrets using the Docker CLI, such as we can make use of your CLI as well as your Docker Swarm API. All right, we can use that also to manage your secrets and deploy these secrets across your cluster. The next question we have is explain Docker container networking modes and their use cases. So like I've already said, your Docker provides us with four networking components. You have the bridge, host, overlay, and the macvlan network. So bridge network, that's the default network, and this helps you to isolate your containers on the same host and provides an internal IP address for communication within a single host. The host network can be used when you want to share the host's machine networking namespace, and this allows the containers to directly access the host's network interfaces, and these can be useful for performance sensitive applications. The overlay network is used when you want to create a cluster of multiple hosts. So this enables communication between containers across multiple Docker hosts that we are running in a Swarm cluster, and this makes use of your overlay networks. Now these are suitable for multi-host deployments and microservices or architecture. So whenever we talk about creating a cluster of multiple machines, we are making use of your overlay network. And then we have the macvlan network, which can be used to assign a MAC address to your containers. And this allows the containers to appear as a physical device on the network. And these can be useful for integrating with your existing network infrastructure. All right, so that's about the use cases we have for these networks. The next question we have is, how do you manage Docker secrets rotation and key rotation in a production environment? So Docker secrets rotation and key rotation in the production environment can be managed by making use of automated tools and processes. So any secrets we take, rotating those secrets is very important so that we don't expose the secrets even by accident. So key rotation essentially involves regularly updating your encryption keys, that can be used to encrypt and decrypt your Docker secrets. So let's say if you have encrypted the secrets, then make sure we are always updating the encryption keys. Docker Swarm also provides us with built-in support for secret rotation, which is allowing you to rotate your secrets automatically at regular intervals. So the general practice is every 90 days we need to change the secret, so we can do that automatically. Additionally, external key management systems and secrets management solutions can be integrated with Docker Swarm, and this provides us with enhanced security and compliance. So we can also make use of your third-party tools to manage these secrets for us. The next question we have is, explain the concept of Docker Content Trust or DCT and how it enhances the container security. Now, Docker Content Trust or DCT, that's simply a feature in Docker which helps you to ensure the integrity and authenticity of your Docker images. So, at any point, if you're using the images that are available in Docker Hub and you want to ensure that the Docker image is very authentic, we can look at your Docker Content Trust for that. So, this essentially uses your cryptographic signatures and certificate based authentication. So with DCT enabled, Docker clients will verify the authenticity of the images and only pulls the images that have been signed by trusted publishers. So DCT is a way where we can make sure that we are only having genuine images and we don't have like any bugs or any viruses on those images, and we are only getting the images from trusted publishers. That's where we can make use of your DCT. So DCT mainly helps us to prevent any unauthorized or tampered images from being deployed to your Docker environments, and this enhances the security of your containers and also the trustworthiness of your containers. The next question we have is, how do you optimize Docker container performance for production workloads? So your Docker container performance optimization, it involves several strategies and best practices that we can follow. So we can make sure we have the right sizing containers. We are optimizing the image layers. Then we are using Docker Swarm or Kubernetes, and we are monitoring and tuning your containers. So when it comes to right sizing the containers, making sure we are adjusting the containers resource limits. It could be a CPU utilization, memory, based on the requirements that your application has, and also the available resources. Optimizing image layers, so this is where we can minimize the number of layers that we are using within an image, and also reducing the size of the image, which will help you to improve the build time and also the runtime performance of those images. Then also we can leverage container orchestration platforms for your auto scaling, load balancing, and high availability. And this can also help you to optimize your resource utilization and also ensure consistent performance for your containers. And then finally, your monitoring and tuning, wherein container metrics like your CPU, memory, network, we can monitor them using tools like Prometheus and Grafana, and also tuning the container configurations for optimal performance and efficiencies. So that brings us to the end of 15 advanced interview questions as part of your Docker. I hope you found these insights helpful in your Docker journey. If you enjoyed this video, don't forget to give it a thumbs up, subscribe to the channel, and hit that bell icon for more content. Share your thoughts or any specific topics you would like me to cover in the comments section. Thank you for watching, and I will see you in the next video.